I'm back with one more lecture. This time my discussion is on relationship between torque and angular momentum. So let's define individually. Now I've got simple body over here which is moving in a circular path with respect to certain axis of rotation, this one. Now this body can move in a circular path only because you apply some linear force, amount of force F, and this r is the perpendicular distance from the axis of rotation to the point in which you apply force. Okay. Now the torque or moment of force or rotational effect of force is defined as r cross F, where r is a perpendicular distance from the axis of rotation to the body in which force is applied, and F is the linear force you apply. And remember, this torque, which is the rotational effect of force, moment of force, depends mainly on r. That means where you apply force, right, as well as the F, how much force you apply, as well as with what angle you are applying force. I mean, so I can write this is r F sine theta with unit vector. So this theta also, it also matters for us for the magnitude of torque. Now one more side I can just define what is L vector, which is r cross P. So again, r is a perpendicular distance, P is just a linear momentum of the body which is moving in a circular path. And the direction of linear momentum is obtained by direction of velocity, because P is equal to m into v. Now direction of velocity can be obtained by drawing a tangent to any point. If I want to know what is the direction of momentum or velocity at this point, draw a tangent, and the tangent will indicate the direction of velocity. Anywhere, if I wanted to find out here, this is the direction. So the direction of linear momentum is along the direction of velocity, and if you take the cross product of r and p, you will get the angular momentum, which is again a vector quantity which has direction perpendicular to the plane which contains r and p, and obviously the L will have the direction along the axis of rotation, as well as the torque, because r and F are on plane perpendicular to r and F. The direction of torque is absolutely along the axis of rotation. Now I want to establish a relationship between torque and angular momentum, as like we have F vector is equal to dp by dt, where F is the linear force and P is the linear momentum, and where the rate of change of linear momentum is exactly equal to the force applied on the body. Now this time also we will have one relationship, and I've written over here, so the same relation we will obtain. Now I'll consider the first equation here written, L vector is equal to r cross P, which is nothing but the angular momentum. Now I will differentiate on both sides with respect to time. I cannot do it for only one side, I have to do it for both the sides. So d by dt, differentiating L vector left hand side, I will do the same to the right hand side, r cross P. Now I'll keep this as same, I won't change anymore, but since r and p you have here parameters, I will just differentiate one by one, because I have to make use of a chain rule. So first I will keep dr cross dt, I mean dr vector by dt, that means the differentiation of r vector with respect to time cross p vector plus, now I will just differentiate p vector with respect to time. So I just use the chain rule. Once I kept r constant, differentiate p with respect to time, next I kept p constant and differentiate r with respect to time. And this dr by dt is nothing but a velocity v, because the rate of change of displacement is nothing but a velocity cross p vector plus r vector cross dp by dt is nothing but the linear force that you apply here, that is F vector. Left hand side I got dl by dt. And now v cross p, this p is nothing but m into v vector, because m is just a scalar quantity, the direction of p and v are same. So v cross v, because anyway you have got m which is a constant, you can take it outside, v cross v is actually equal to 0, because cross product of two same vectors is always equal to 0, because v cross v is v sine theta, theta is 0, sine 0 is absolutely 0. So r cross F you are left with, so dl vector by dt is equal to r cross F, which is equal to the torque I have already defined. So I got a relationship between the torque, external torque applied on the body which is in rotation with respect to certain axis of rotation, and the angular momentum, that is L, with respect to time. So I just established a relationship here. The external torque acting is equal to the rate of change of the angular momentum. Thank you for watching this.